Hey everyone, it's Ramon here. I just wanted to run a quick exercise on creating and interpreting density curves in RStudio. Density curves are my number one visual graphical analysis to go to when I'm working with distributions of data. So it's my favorite way of looking how the data is distributed. So I'm going to walk you through some of the code in here. This tutorial assumes that you have some experience with RStudio, so I'm not going to show you exactly how to open it and load out the code and all of that, but I will walk you through what I did here. So first and foremost, we are going to need the tidyverse library for this. I'm going to execute that line of code, and also I have the ggthemes, which is an additional package to ggplot, just to make the plots a bit prettier than they normally come in the regular package. So I'm going to run that code as well. Now for the data, I'm just using the rnorm, which is a function within rbase to create random data, in this case normally distributed. I'm calling my object male for the first one, and then I'm running 100 data points. My mean is 78 inches. And my standard deviation is 2. Again, if you're familiar with the basic R code, you will find this function very useful. I'm simply creating random, normally distributed data. And let's run that code. So Control Enter will run that code. And then I'm going to create another object, female. And in there, I'm going to also create 100 data points. Now I'm going to use 72 inches. So this is just a study on hypothetical data for heights. And then the standard deviation, purposely, I put it a little higher, 5. And you'll see this in the density curves. So let's run that code. Now, what I want to do next is create a data frame with both variables. So I'm using the data frame code in R, and basically calling what it is. Male, it's from the male object, and then female, uppercase, from the female object. And I'm going to call this object df. Run that code, a quick check, head df, and then you can see down here that that's exactly what I just did. I created 100 data points, and then I have my male and my female columns listed with the randomly created data points for each of the categories. The only last thing we need to do here is, because I'm using ggplot works better with long form. So basically I want to put this all in 2 columns, like basically gender and height, so that I can actually run ggplot more efficiently. Some cases ggplot won't even run if it's not long form. I'm using the function melt here to create this long form data frame. The variable names, I'm telling RStudio to pick up the male and female, which are my variables here, and put it in the column called gender. And then for the values, I'm putting in a column called height. So very simple code, but just so we run ggplot smoothly. Created the data frame, and then check again using the head function. And there we go. We have here the gender in one column, and then the height. You can only see the first 6 records, but the female should be there as well. All right, so there's a lot of code in here just to make the plot a bit more visually appealing. I'm not going to spend too much time on that. So all of this code in here, the theme, the labs, the title, adjustment, this is all for the better visualization of the plot, optional things. The important thing here is to use a ggplot function, of course, and then bring your data set, which I called here data. The aesthetics, I want the height, which comes from the values, to be in my x-axis, and then I want the field to be by gender. And also I'm using the facet wrap for the first run of this plot, just to show you how it goes. So let's execute this code. And then what you see here is 2 plots side by side. On the left side, I have the male, and you can see how the distribution is tighter, picking around that 78 mean value that I set with a 2 inches standard deviation. So again, purposely done just to show you visually how this looks like. And then on the right side, I have the females, which again, I purposely used a higher, greater value standard deviation to show more spread, more dispersion, into the data set. So this is one way of looking at the data, but let's see how we can do kind of the same by looking at different plots that are more efficiently in terms of the visualization of the data, especially the overlap of the two data sets. So I'm going to run this code now, which is basically the same. The only change here is the facet grid. So instead of the facet wrap, I'm using the facet grid function within ggplot. And if I run the code, this is what it's going to look like. Same thing, but now I have one plot on top of the other. It's getting better in terms of comparisons because I can see the peak of the data here around at 78 inches, and I can see the peak of the data here for females around at 72 inches, and I can see the spread. Again, this is more spread. There's more dispersion in the data, which again, I purposely use a higher standard deviation to showcase this. And this one, it's a bit more concentrated, a taller, higher peak type of concentration. Now, the last one, it's my favorite one. I think is the one that is more telling in terms of comparisons. The code is basically the same, but now I don't have the facet grid or the facet wrap. I'm just running the geom density. Everything else is basically the same. But what this does is gives me the overlap of the two curves. In my opinion, this is the best way of making this type of comparisons. Now I have here the males in green, again, higher peak, more concentration around the mean, less deviation. I set the standard deviation at 2. And then you have the females, again, concentration around the peak, the mean, which is 72, purposely calculated that way, and then more spread, more standard deviation. Overlapping is where you see both curves on top of each other. So you can see the area actually that actually has the same heights, like, the males and females that overlap in terms of, in this case, again, heights. The cool thing here about ggplot using the geom density, you have this alpha option within the geom density, and you can change that to make it more transparent or less transparent when you're looking at the overlap of the curves. So for example, I can make it super clear, 0.1 for example, and you can see that you can barely see the colors, or I can go all the way to, like, say 0.9, which is going to make the colors a bit more solid, not as transparent, but then you start losing that overlapping visual. So I kind of like using 0.5 to 0.7 depending on the color palette, the color scheme, and then you can clearly see which one is which and how they overlap. So again, a very, very useful way of looking at different data sets, not only two, but you can do this using various data sets for comparisons. You can see the central tendency around the mean, you can see the measures of this dispersion or spread, and clearly see how they overlap. So that was the tutorial for today. I hope you learned something here, and I hope to see you next time.